Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. So for the first activity 1 is for the exercise 7 or 8 in here. We are using the MATLAB simulink to construct the block diagram of an open loop speed control system as shown in the figure 8.4 in here. So set the parameter value according to table 8.1. So we are already the value already according the table 8.1 in here. So let's go to MATLAB. So this figure 8.4 in here. This input voltage in here. So let's rerun it. So the value in here set 0 until the 240 voltage in here. So this 240 for the input voltage, and 11.02 is motor torque, and 3695 for the motor speed, and 240.2 is for the tachometer voltage. So let's see the graph. So this is for the input voltage in here. There's a graph for input voltage. So constant in here at the 240. For the motor torque, the graph they increase in here until 47 I think in here. So they decrease slowly the curve until in 10 seconds above 10 volt in here. So for the motor speed graph is it increase from the 0 until 10 until to the 3600 in here of the RPM. So it increase with the curve in here. So for the tachometer voltage, so from the 0 until the 10 second in here. So 0 until to the 240 I think here, 240 in here. So that's all for the graph for the figure 8.4. So let's go for the next simulation for the figure 8.5 in here. So it is like the same, but it add the tachometer constant in here. So let's go for the simulation. So for the first is the 400 until 260 2600 in here. So for the MATLAB, so this for the second simulation in here. So first this for I think this is 400. So all this 400 RPM in here, the input speed. So let's run. So we get the value that so the question 1 is the input voltage and the tachometer voltage. So let's go see it. So for the input voltage is 26, and for the tachometer voltage is 26.02. So I already find the answer for all simulation. So this output in here. So the 400 until 2600 in here. We have 26, 52, 78, 104, 130, 143, 156, and 169 for the last simulation. For the motor speed 400, for the tachometer voltage in here 26.02 until 169.1. So if you can see the difference between of input voltage and tachometer voltage, they are a little only different in here. We have the point in here, but this they are not what's that the number behind them. There are no point in here. So there's a voltage S. So let's see the graph for the input voltage and versus motor speed. This is for the graph for this result. So they increase, and input voltage increase, motor speed also increase in here. The straight line is the 1 equal to 0.065x. This is a straight line. For the tachometer voltage versus the motor speed is y equal to 0.065x plus 0.0138. so the difference is we have the number of behind them, and for the input voltage there are no, so the voltmeter has in here. So that's all for the simulation for the activity 1. Thank you.
Hello, Assalamualaikum. My name is Elisa Afira binti Azhar and my car metric number is AE190067. So I am in charge for activity 2. So for the first step, we need to find the input voltage for speed 2500 rpm. So for the step block parameters, we put the final voltage for the final value is 2500 and sample time is 10. I connect this on the block. And change the rate to 0. So for speed 2500 rpm, the input voltage is 162.5. So and the next step is we need to find the speed with different value of brake scale. So for we need to set this value to 162.5 volt, and this one delete this because of voltage value. Just connect it again. So for brake scale 0, the speed is 2502 rpm, and change it to 3 as an example. So now the speed output is decreased to 2271, and this is the graph from the speed versus times. So I think that's all from me. So thank you.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Fikri Haris bin Suhawi. Matrix number is AE190001. Right now, I'm in charge to explain about the simulation for the activity 3 in exercise 8. Okay, for the first one, we need to disarrange all the parameter. So then we can just connect each other. Just connect all these parameters. Just follow the condition that asks from the question. Okay. This activity 3 asks us to find the motor speed output. Then the first thing we need to do is we have to set up this value. For the step time we set to 0. The initial value is 1C2.5, and the final value also 1C2.5, and the sample time we set it to 10. Okay. After that, this display will show the value of the motor speed output, and this block will show the graph for this motor speed output. The first thing we need to do, we set the brake with the value of 0. We have to try for different value, which is 0, 3, 6, 9, 12, 15, 18 and 21. But I will show you for 3 examples. The first one is 40. Okay, we run the simulation. Okay, right now you can see the value of the motor speed is 2488 RPM, and you can see the graph is like this. This is the graph for the first value of brake 0. Okay, we can try for another example. We just change the value of brake. We change to 3. We run. As you can see, we can find a different value when we change the value of brake. You can see the value is 2486 RPM, and the graph is slightly different from before, which is different from here. Okay, I'll show you another one example. We change it to 9 and we run. Now we got another value, different value. The value is 2484 RPM, and the graph is like this. I think that's all from me. Thank you.